and a lesson will be assigned to you on Edpuzzle. And you'll be responsible for catching up with that by the end of the school week. All right, so let's get started. We are starting with Unit 8, Lesson 2, Naming and Drawing Branched Alkanes. So I'm going to review a couple things with you before we get started. The first thing is you have to know valence electrons for this unit. You have to know how to get valence electrons. How do you get valence electrons? The group of the periodic table, right? So in this specific unit, we're only going to be looking at non-metals because organic compounds only have very few elements involved. Organic chemistry consists of carbon, so it's going to be carbon and what carbon is covalently bonded to. So you're going to have to know that all the elements in group 14 have how many valence electrons? 4, right? All the elements in group 15 have how many valence electrons? 5. All the elements in group 16 have how many valence electrons? And all the elements in group 17 have how many? 7. And then hydrogen has how many? This is extremely important information because this tells you how many covalent bonds each of those elements will make. And that's really important when you get to large complex molecules. How many bonds can hydrogen make? 1 bond. Because it can only make 1 connection and its max is out at 2, right? How many bonds can everything in group 14 technically make? 4. So you should note that. Everything that's in group 14 can make 4 covalent bonds. It's got 4 single electrons. What about group 15? No. 3. So it's a single electron. Everything in group 15 can make 3 bonds to get to its nearest noble gas, and this is extremely important information moving on. Group 16, what about that one? 2 bonds, because it can only make 2 connections with its 2 single electrons. Remember, only if they're single are they able to mingle. That was the jingle I gave you. Group 17, what about that one? 1. This is really important information because that tells me that any halogen cannot be in the center of a compound. If you write an organic molecule and you write this, guess what? That's not right. That's completely wrong. And I know immediately if you put a halogen in the middle that that doesn't work. This is something that does not exist in that manner. And so when you're drawing with structures, you can use this information to help you know how they're organized. So you should know your valence electrons for these different groups and for hydrogen. And you should know that halogens never go in the middle of compounds. What else never goes in the middle? Halogens cannot be in the middle. What other element can never go in the middle? Hydrogen. Correct. If you write hydrogen in the middle, if you write something like this, I can already tell you you're going to fail your last exam. It's gonna be because you're not paying attention to the very simple things, which is hydrogen can never be in the middle because it can only make 1 bond. It has to be on the outside. That's really, really important ideas. You've got to have an idea of that. That comes from earlier in this class, actually. We learned this back in, I'd say, Unit 3. Unit 3 is where I like to say this. So that's just a brief reminder of things you should know going into this class. The next thing is, this is from Unit 8, Lesson 1, what you were supposed to understand out of that lesson. So I want you to write display the structural and the skeletal formula for the molecule butane. This is a check-in. What does ANE mean? The ending ANE. What does that mean? Butane. Single bond. I heard somebody say it. So this means that all my carbons are single bonded to each other. If the ending is ANE, that is what this communicates. And what does but communicate? carbons. Now look at that one sheeter I gave you. Even if you didn't do the lesson, I gave a summary sheet that has everything that was important from the first lesson. What does butte mean? 4. And I gave an acronym. If you watch the video on an easy way you could memorize that. Monkeys eat peeled bananas. Meth, F, prop, and butte. And that'll help you memorize the order. Look at that. Yami, to go to the bathroom. Did you return the pass? Yami, please take the pass. So butte means 4 carbons. So then, what is displayed formula? What does that mean? You're showing every covalent bond that exists in that structure. So when we're drawing this, to draw the display, like I said, if you didn't pay attention or you forgot, you need to make sure you're paying careful attention right now because I'm reteaching this. Display. Start with your 4 carbons in a row. Because butte means 4, and they're single bonds only, right? So C, 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 like this. Got it so far? Then, what you have to know is that if carbon isn't connected to carbon, carbon is connected to what other element in alkane? Hydrogen. So the idea is that you fill with hydrogen. So after writing your carbons out, you fill with hydrogens until when? Until when? I don't know how many hydrogens to place. Until all carbons are stable. And we learned a while ago, and I've had this here for like 5 months for a reason. Carbons are stable when they have 4 bonds. And so we would fill the left carbon with how many hydrogens? 3. Because that will give that carbon 4 bonds. It'll be stable with the top temporal. Yes? The carbon in the middle here, how many hydrogens? 2. The carbon, other carbon in the middle, 2 as well. And the carbon on the right hand end? 3. And so the displayed formula is the same as the Lewis structure of path. However, it's tedious. And the larger the molecule, the more carbons and hydrogens you have to write. So because it's so tedious, people have come up with simplified ways of writing organic molecules. And so the first way was called displayed. And this is really just the Lewis structure. It's the full structure. It shows everything. The second format is called the structural format. So what happens in the structural format?
Subscripts.
You use subscripts. And the idea of the structural is you write each carbon in the carbon chain, and then you write what's attached to that carbon. This is going to come back into play in today's lesson. So what I did when I taught it, I believe, on the video is I circled around this carbon. How many hydrogens are attached? So you would write C, H. So instead of writing all the bonds to hydrogens, you just say, okay, I know that there's 3 hydrogens attached to this carbon. The one here, how many hydrogens are attached? So you write CH2. The one here, how many hydrogens are attached? And then here, CH3. And that's what we call the structural format. It saves a little bit of writing. The skeletal is the least amount of writing. In the skeletal format, all you do is write what appears to be zigzag lines. And at the end of every single one of those line segments, it is implied, you're supposed to understand that there's a carbon at the end of every one of those lines. And you just have to know how many hydrogens each of those carbons have, like off the top of your head. So the skeletal format for butane would be in the following manner. This is the same molecule. specify at the end of this line right there is a carbon. So a lot of times I'll write little dots to show where the carbons are at. There's a carbon here, a carbon here, a carbon here, and a carbon here. And you're just supposed to know if carbon isn't attached to carbon, the rest of the atoms are going to be hydrogen, but we just don't write them. We just know they're there. So this is the skeletal format, what we call the skeletal format. You should write these down in your notes. The other thing you were supposed to pick up, so there were two major things you were supposed to pick up in the first lesson. The first one was how to write display formula, how to write structural formula, and how to write skeletal formula. So that's what I just went over here. The second thing you're supposed to pick up is the naming strategy, or at least the beginning of the naming strategy. Meaning, you are supposed to memorize, yes. This is one of the, there's going to be two major things you have to memorize this unit. This is one of them, along with the naming strategy today. The other one's going to be called functional groups, which will be in the final lesson. Those are the major things you're going to have to memorize in this unit. These prefixes tell you the amount of carbons you have. So you're supposed to interpret these prefixes, and this tells how many carbons you have. So if I say octane, you now are supposed to interpret, oh, that's 8 carbons. And then the ending, the ANE, tells me that they're single bonds only. That's what the ANE tells me. So if I see propane, it tells me there's 3 carbons, and all of them are single bonded to each other. And that's what this naming strategy gives us. You're going to want to keep your one-pager on hand because you'll need it today, because we're going to add more now into, this is all the old stuff. This was all from that first lesson. So now we're officially going to start to begin, well, what continues from here. In the first lesson, you were supposed to learn something called straight chain alkane. What is a straight chain alkane? Straight chain. What does that mean? Straight chain. All the carbons are in a, they're in a row, like this. C, etc. Right? Straight chain means just all your carbons are linked neatly together. Molecules are more complicated than that. They branch out. And so what you're going to learn today is something called branched chain alkanes and how to name for those. So straight chain means all your carbons are in a row. I'm pausing to give you some time. Branch chain alkanes. So let me give you an example of a straight chain. An example of a branched chain. And then you can spot out what's the difference. What's the difference between the straight chain and the branched chain? So on both of these, we've got 4 carbons, right? But in the straight chain, all 4 carbons are in a row. Whereas in the branched chain, how many carbons are in a row? Only 3 are in a row, and 1 is hanging off. This carbon that's hanging off has a fancy name. It's called a substituent. And so that's what this word, substituent, is. It's any group that replaces hydrogen on a chain. We call that a branch. It could be a carbon. It could be oxygen. It could be a chlorine. There's somebody out right now. We call these substituents. So anything that's off the chain. Bless you. And we're going to have to learn how to draw molecules with substituents, and we're going to have to learn how to name molecules with substituents. I'm going to write the names here, and I'll see if you can kind of get the hang of what this is. So this right here is butane, and this right here is 2-methyl-propane. Look at that name. See if you can figure out why I named that 2-methyl-propane. I'm going to go over the official rules shortly, but I know that you're all very savvy. You could probably figure at least some of this out. Why would I call this specific molecule 2-methyl-propane? Where's that coming from? So how many carbons did I say that were in a row here? 3. What's the prefix for 3? So there's the propane, right? Propane is telling you how many there are in a row at the end. So what's the other part you think? Meth stands for what?
1.
1 carbon. What do you think the 2 stands for? If I were to number these carbons, right? The second carbon, the one in the middle, is the one that has the meth group on it, and then the ill means it's a substituent. And so that's the general naming strategy. You're going to see this step by step shortly, but this is how your names are going to look very shortly. The next thing here is very similar, actually. There's going to be pieces of a puzzle that we're going to have to put together. And by the end of today's class, we're going to have a whole puzzle that's put together. And so the first piece of the puzzle when you name with substituents is figuring out what's your longest carbon chain. So the longest continuous, you should circle that word. Continuous means in a row. The longest continuous carbon chain of a branched chain hydrocarbon, we call this the parent chain. And this gives the end of the name, always. You'll see that in a little while. But 3 carbons means the end of the name is going to be propane. Here you see there's 1, 2, 3, 4, 5, 6 carbons. So we know the end of the name is going to be hexane because there's 6 in a row. Any other carbon or any other element that is not hydrogen, that's not part of that chain, are substituents. This can include halogens, oxygen, nitrogen, and carbon. I didn't get to tell your class. I told the A-Day classes and I think period 4. But in organic chemistry, we work with very few elements. I mentioned that earlier today. For today and next class, we're only, and probably the class after even, we're only looking at 2 elements, carbon and hydrogen. We're not even going to expand. I think we'll expand into halogens next class, but we're barely going to expand until next week. And when we expand, we're only expanding to oxygen and nitrogen. So we look at very few elements of the periodic table in the study of organic chemistry, but yet there's millions and millions of molecules because of all the ways carbon can combine. All right, so a hydrocarbon that's off the chain is called an alkyl group. And so what do we mean by that? It was mentioned if you have, for example, this idea that you've got 1 carbon off the chain. This is going to be called methyl. Meth stands for 1 carbon. Il stands for off the main chain. If you've got a different carbon chain, let's say you have this, and you've got this going on. Look at the one at the bottom I've just drawn. How many carbons are off the chain there? 2. So if I see 2 carbons off the chain, what's the prefix for 2 carbons? F. And then off the chain is going to be il, the alkyl group. So this is called ethyl. And that can move forward. Meaning if you had 3 carbons off the chain, it would be called propyl. If you had 4 carbons off the chain, it would be called butyl. So the idea is that the il ending indicates it's a number of carbons off the chain. So that's what the il indicates. Methyl means 1 carbon off the chain. Ethyl means 2 carbons off the chain. So that's what it says here. Alkyl groups are named. You take away the ane ending to the normal ane ending, like methane, ethane, and you change it to il. And that's what tells us that it's off the chain, that it's not on the main carbon chain. It's not part of the main carbon chain. Welcome back. Xavier. Giving a little bit of time, then we'll go to the next piece of the puzzle. You'll find out. Coming soon. Coming soon. All right. So the next thing is just because I'm not exactly sure where to place this information. It actually becomes really important in the later course, not really so much here. But carbons can be categorized by how many other carbons they're directly connected to. So a primary carbon is a carbon that's only directly attached to one other carbon. So this means that you have a carbon attached to one carbon. A secondary carbon is one that is attached to 2 carbons. So this carbon in the middle is connected to a carbon on the left and a carbon on the right. We call this a secondary carbon. A tertiary carbon, and you can see the prefixes are telling you what's going on. Primary means 1. Secondary means 2. Tertiary, the prefix ter can mean 3. So 1, 2, 3, and quat can mean 4. Actually, so that's what that means. Is that if I have a tertiary carbon, that means that I've got a carbon that's connected to 3 other carbons directly. Carbon, carbon, carbon. And then finally, a quaternary carbon is one where you've got a carbon that's attached to 4 carbons directly. So carbons can be attached anywhere between 1 and 4 other carbons because carbon can make 4 bonds. So it can be attached between 1 and 4. Why does this matter? It doesn't really matter too much at the previous level, except that you just know of its existence. But it actually has everything to do with a chemical's reactivity. So when you start to learn about organic reactions, which is not a previous topic, but when you start to learn about organic reactions, actually how reactive a chemical is based on how many carbons are attached or how many groups are attached. So it's interesting stuff moving later on. To be continued. At this point, just recognize primary means carbons attached to 1 other carbon, second means 2, tertiary means 3, and quaternary means 4. There's terminology. All right, I already brought this up, but it's here. This is a piece of the puzzle. These are the names of the hydrocarbon substituents. These are the different ones that you are likely to encounter. You are unlikely to encounter any groups larger than butyl because you're only tested on carbon chains that are lengths of 1 through 10. And so you can't get a substituent larger than, I think, pentyl, which would be 5. And you'll see why shortly. So if you have one or more of these methyl groups, ethyl groups, propyl groups, whatever, we call these a branched chain alkane. Not all your carbons are in a row anymore, and you're going to have to draw these appropriately, like I said, and name these appropriately. All right, so chemistry jump scare coming shortly. The rules for naming are kind of tough here at their first outset. When you first learn them, it seems kind of tough. But as you practice them, it's always the same naming rules over and over again for the rest of the unit, so you'll get the hang of it over a while. This is where the colors are going to need to come into play. So you're going to want to have those either highlighters or different colors ready to diagram molecules because you're going to need to figure some stuff out as we go along. So let's read through the rules as we always do, but then we'll go through the rules with each example. I have a couple of questions in there that say your turn. Those are going to be the ones for stamps as we go along. Remember, I'm still doing stamps. If you get 2 stamps and you've saved your notes for the final note check, I'll be adding every 2 stamps you get is 1 additional game point at the end of the year for your final update. All right, so here's the rules. The chemistry jump here. I apologize in advance, but these are the rules. To name branched chain alkanes is much more complicated than to name straight chain alkanes because you've got to make a bunch of considerations. So let's take a look at the rules. IUPAC, if you have no idea what that is, it's an acronym. It stands for the International Union of Pure and Applied Chemistry. So these are the people that set the rules. And every organic molecule that's named follows these, and created is named after these specific rules, so everybody across the world has the same understanding of what you've made. So that's why everybody follows the same rules. So for naming branched chain alkanes, we're going to do this. The first thing we're going to do is name the longest continuous carbon chain, which means when you're going through your own questions, you first have to find it. So you're going to want to find the longest continuous carbon chain. You have to find and name it. You don't highlight here now, so you get to the practice question. Then you're going to circle. This is where we start using your colors when you get to practice questions. Circle any groups you find that are off the chain, that are not included in that longest continuous carbon chain. By groups, what do we mean? We mean any other carbons that aren't part of that main carbon chain. You're going to circle those. We call those substituents. And they're going to have to get named. Rule 3 is usually the one that confuses people the most, so you're going to want to make sure when we do questions that you're paying careful attention to how it's presented. Number, meaning in a row, the longest continuous carbon chain. And you have to do it in such a way that the substituents get the lowest numbers possible. Meaning, you may not always be numbering left to right. You may be numbering right to left. You may be numbering bottom to top. Whatever gives your substituents the lowest numbers possible. And we'll get to that when we get to examples. What does that look like? Then, step 4. Name each individual substituent. I do suggest naming them separately and not trying to skip steps. You can go very wrong if you try to skip steps here until you're comfortable with it. You must put the number of the carbon that the substituent is on in the parent chain. So if you see 3-methyl, I mentioned this earlier, what this tells us is that the 3rd carbon in the longest carbon chain has a methyl group, which means 1 carbon long coming out of it. Back. Okay, row 5 is another confusing one. We'll get to it when we see it. If there are 2 of the same type of substituents, Daniela brought up, well, what if there's more than 1? What if there's 2 or actually a way to group them together. You group them together and you write di, you have 2 of the same group, tri, you have 3 of the same group, and tetra, if you have 4 of the same group. And it would be penta 5. If there are multiple substituents, and what I mean by that is multiple different substituents. For example, let's say you had ethyl and methyl and chloro. You alphabetize these different substituents by their first letter, meaning that ethyl always comes first, then methyl, then propyl, and you may want to write this down. I used to remember it as EMP, which looks like the thing in Call of Duty that I remember. EMP. We will be going back over these rules as we look through examples. It's pretty hefty, but as you go through and practice them, they are the same rules over and over and over again. Just like when you first learned how to draw loose structures and you first learned how to complete and balance equations, there's always a set of rules to follow. Okay. So, this is the general structure of your name, how you should write your name out. The substituents are always going to go in front, and then at the end you write the name of your parent chain. So remember that your substituents are alphabetized. So if you have multiple substituents, you're going to alphabetize them, and then you write your parent chain at the end. So let's take a look at practice. Following the rules, what do we do? This is where I said you may want to get your colors out. Choose a color, and the first thing you're going to want to do is you're going to want to put a line through your longest continuous carbon chain. How many carbons can you get in a row here? I agree. 4. First few examples will be simple to spot out, then it will get more complicated. This tells you your parent chain. What's your parent chain? If it's 4 carbons, this tells us that the end of the name is going to be what? Look back at the one sheeter I gave you. Use. Butane. So we know the end of the name is going to be butane. All right, let's go. You've got the papers in front of you with the rules on the same page. Slide 10, right? We did step 1. Step 2, circle any groups that are off the chain. Do you see what's off the chain here? Groups. Would hydrogens be considered off the chain? Yes or no? What do you think? Hydrogens are always there. They are not part of the name. So what's off the chain? So you're going to want to circle that. So circle this. This is the only group that's off the carbon chain, meaning we've now accounted for 4 carbons, but we still have the name that fits 1. We have to incorporate that into the name. So then, step 3. Number the longest continuous carbon chain in such a way that the substituents get the lowest numbers possible. So you're going to have 2 options here. This is your one end of your longest continuous chain, and this is your other end, right? So there are 2 ways you could number your chain, but only one of them is correct. And it may help to do this in different colors. Your options are left to right. 1, 2, 3, 4. This is left to right. And the other option would be right to left. 1, 2, 3, 4. Which is the correct way to go? Right to left or left to right. It says number the longest continuous carbon chain in such a way that the substituent gets the lowest number it could possibly get. The substituent you've circled. It has the option of being on carbon 2, or I'm being carbon 3, which is a lower number. Like the number is smaller. 2 or 3? 2. So that means that in this molecule, the way that this is written, we should be numbering left to right. That would be the correct way to number. So that would be the correct way, purple way, for me. Will right to left be correct sometimes in some molecules? Yes. It's whatever gives your substituents the lowest number. If you're a visual person, you may be able to see this pretty easily because whichever side, whichever end the substituents are closer to, that would be the one that you want to place carbon 1. So it'll be closer to that. All right, so now I know it's going to be the purple way, the blue way is not right. How do I name this substituent? The one that I circled. This is step 4. It is on carbon 2. It is 1 carbon long. How do we name it? 2 stands for the carbon on the chain it's on, so location. So number actually tells you tells location. So if I see a 2, that tells me what number on the carbon chain, which carbon it's on. It tells me the location. And then meth stands for what? 1 carbon. And then il means off the chain. And so that's the name, 2-methyl. There rules 5 and 6 don't apply here because there's only 1 substituent. So what would the final name be? Remember, the general structure is substituent first, then parent chain name. 2-methylbutane. Yeah, Damon, you can go. 2-methylbutane. Yes? All right, well, trying 1, that's, first of all, that's the simplest example. Second, you haven't seen all the different scenarios yet. So we're going to do a few more examples together before you have one to try yourself, seeing that we can work through these strategies. So like always, I try to give the simplest example first, and then I step it up a notch. So we're going to step it up 1 notch. Step up 1 notch. We're going to follow the same rules again. They're the same rules. How many carbons in a row for my longest continuous carbon chain? 4. Again, right? 1, 2, 3, 4. 4 carbons means the end of my name is again butane. That's my longest continuous carbon chain. That's the name of it. Butane. What's the next step? Let's circle any groups that are off the chain. Do you see any? Anything that's not part of these 4 carbons?
CH3 on the top and
There's
CH3
1
on the
here.
bottom.
There's 1 there. Would you say this is 1 group coming off the chain or 2 groups? 2 groups. This is really important because a lot of people make mistakes here. Each must be named separately first. I'll explain why I'm saying this shortly. But this is 2 separate groups, right? A carbon coming out that way and a carbon coming out that way. Like saying I have an arm going this way and an arm going that way. 2 separate arms, right? They may be coming out of the same area, my shoulders, but they're going 2 different directions. So then, the next thing is to number my chain. Should I be numbering this carbon chain left to right or right to left? Once you get a good feel for it, you'll just be able to figure it out. If this is my first carbon, then my substituents would be on which carbon in the chain? If I go left to right.
It's going to be left to right because the smaller number will be instead of
Right.
the other way around.
And if I went right to left, which is a different color for that,
3.
my substituents would be on carbon 3. You're like, Missy, why are you even bothering? Because there'll be a time where right to left is the correct way to go. So it's not correct because it's not the lowest number direction. And you could do that in your head. Like once you get good at it, you can just trace it. Like go 1, 2, 3, 1, 2, 3. Which one's the lowest number? Got it. 2 is the lowest number here, right? So we're going to be numbering left to right. The next step is to name each of these substituents individually. What's this one on the top named? It's 1 carbon long. It's coming out of carbon 2. 1 carbon long means what prefix? Meth. And off the chain is ill. So it's 2 meth full. And yes, I mentioned this to the other classes that I was able to teach the first lesson to. The prefix methamphetamine, like methamphetamine, the drug, if you might think of that, that meth does stand for 1 carbon hanging off the chain somewhere, actually. That's where it gets its name from. This is not methamphetamine, but that's what that prefix is.
No, bad idea.
All right, methyl. What about this one down here? What's the name of this one? Same thing. So you should write it. And the reason why is because we now need row 5. If there are 2 of the same type of substituent, group them together and write die in front. So what does that mean? When we put this together, we're actually going to call it 2, 2, and you want to write this down exactly as you be writing this. Dimethyl. What does that communicate? 2 of the same group, and you have to say what location each of them are on. Why do you have to say which location each of them are on? Anybody have an idea? Right. So what if you have this? I'm just going to bring this up because this exists. This is a methyl on carbon 2. This is a methyl on carbon 3. What I've just drawn up here is 2, 3 dimethyl butane. See if that makes sense to you. So if you've got multiple of the same substituent, you've got to group them together. You write di if you've got 2, tri if you've got 3, and tetra if you've got 4. That's what those di, tri, tetra prefixes are for. It's for amounts. So this tells amount. Whereas these numbers here don't tell amount, and that's one of the confusing things. The numbers don't tell amount. What do they tell? Location. Tells location. So this is just to help you diagram it, because once you get the hang of it, it's not difficult. But this is definitely the most difficult idea of the unit to understand, especially at the beginning. Yes. Because if you went right to left, your methyls would be on carbon 3, and you would have named it 3,3-dimethyl, and that's not the lowest numbers possible. According to the rule, you've got to give the lowest numbers possible. Ready to step it up another notch? So we've now encountered, oh no, what happens if I've got 2 groups? That's what we've encountered so far. The next one is going to be a step up. Ready? What's up with this one? Okay, so you breathe in, you breathe out. Follow your rules. What's the first one? Find your longest carbon chain. How many carbons can I get in a row here?
Oh, wait.
This is where I said if you're visual, you're actually going to figure out which way to number right away. It is 7, right? So that's why I would put a line through it. Those are my 7. And 7 carbons means the end of the name is going to be what? Hex. So 7 carbons equal hexane. We know that the end is going to be hexane. Now, if you're a visual person, you may get this right away. Should I number this left to right or right to left for my substituents? Which way will give you the lowest numbers possible? It's gonna be right to left. Because look, everything's like on that side, not on that side, right? So it should be right to left. You can write both as you're getting comfortable with it. So your left to right would be 1, 2, 3, 4, 5, 6, 7. That's your left to right option. Your right to left option, I'm going to write in a different color, is 1, 2, 3, 4, 5, 6, 7. If you go with left to right, your substituents will be on carbons 4, 5, and 6. If you go with right to left, your substituents on carbons 2, 3, and 4. What's a lower set of numbers? 4, 5, and 6, or 2, 3, and 4? 2, 3, and 4. So you have to give. Thank you. Are you coming back in?
Yeah.
Thank you. So sweet. Oh no. Smack that in the middle of the lesson. Just breathe in and breathe out. Like this is not the easiest example. Okay. So, are we good with right to left being the order? So, cross out the left to right, that's not right. Because it's not the lowest number. The lowest numbers are right to left here. So then, what comes next? We're going to circle the substituent. Right. That is part of the process. Circle your substituent. So knowing this is on carbon 2, what's the name of the substituent? On carbon 2, meth means 1 carbon long, and ill means off the chain, right? What about this one? 3 meth. And what about that?
4
It's 2 carbons long, right in a row, coming off the chain. Off of carbon 4, it's 4 ethyl. Following me along so far? Now, when you have different types of substituents, notice that you've got both ethyl here and methyl here. They are different. One is 1 carbon long, the other one is 2 carbons long. What did Rule 6 say you had to do? If there are multiple different substituents, you need to alphabetize them. Meaning ethyl will always be written before methyl. Again, if you want to take a picture of this. So what would be the appropriate order? So it would be, remember, it's the substituents first, plus the parent name at the end. So we start with 4 ethyl. That is alphabetically 4 ethyl. So it's really important that you do it in this order so you don't get confused. We do the ethyl first. Now we do the methyl. But we have to gather them together. So there's a 2-methyl and a 3-methyl, so we write it as 2, 3 dimethyl. Why I said you should order it this way. You'll notice in Rule 6 it said the di-tri groupings do not apply to alphabetizing. So you're only alphabetizing the name of the main group, ethyl versus methyl. They get confused and put the D in front of the E if you don't do it the way I'm doing it right here. It's ethyl first, then methyl. The di doesn't for alphabetizing, the di's and the tris. That just tells you how many of that group. So 2, 3 dimethyls, and then what? How do we close it out? The end of the name. Heptane. So it looks pretty crazy. Like, what? You were close. Yeah. Notice between numbers and letters you put dashes. That's something that you should make a note of. Between numbers and letters in this naming strategy put dashes. That is the official strategy from the International Union of Pure Applied Chemistry. And it's all one name. There's no spaces. This is not a, you wouldn't be taking a typed test, but like it's all one word. 4-ethyl 2,3-dimethyl heptate, all one word. All right, so what made this one trickier than the first two that we did? What were the scenarios here that we've now approached?
Longer parent name and more substituents.
More substituents, different substituents, and also you
Location.
don't always go left or right. Sometimes you may have to go a different direction to get the lowest numbers possible.
What if it wasn't like, if you have like one carbon on the, if we want to write that, if you have one carbon on 6 and one carbon on 2.
It's the lowest set of numbers possible. And if it was exactly the same either way, then it would try the previous equivalent.
Yeah, but it wouldn't be the same value.
Then you go with the lowest set of numbers, which means you add them all up and see what gives you the lowest, like total number, if that makes sense. Like 2, 3, 4, if you add those three numbers, it's way less than 4, 5, 6. So that's what you have to consider when you're naming. Okay, we're stepping it up another notch. Breathe in and breathe out.
We're making space H leaps.
What's the trick here? There's a trick. I'm telling you in advance.
It's right to left.
There's a trick. There's something way off about this.
The substituents.
What is step 1?
Parent name.
The longest continuous carbon chain.
Substituent.
How long is the longest continuous carbon chain here?
Oh wait, no.
Five.
One of those. Oh yeah, it's 5. The parent and the substituent.
It's not 5. It's not 4. This is carbon chain.
Oh.
Oh what?
That's why I said get your colors. You should diagram this. What does the word continuous mean? In a row. This is a row. Do you agree this is my arm? Is this my arm?
Yes.
Are you sure?
Yeah.
I didn't just cut it off, like half of it off? So it's still as long as it was before?
But you have
So
to
this is the longest continuous carbon chain. Count it. 1, 2, 3, 4, 5, 6. That's not 7. 7 was the longest. So I'm expanding your brain a little bit. You have to check on all sides how long your continuous carbon chain could be. I'll show you something after this. I'll show you a couple things after this. But let's name this one. Now that you know that this is the longest continuous carbon chain, that's how many carbons in a row are here? 6 carbons, which means it's hexane. Now what comes next? Circle, circle. Those are 2 different groups. They're both 3 methyls. This would be the right way to go. Left to down. That. If you go down to left, it would be 1, 2, 3 to left. And 3 is less than 4. So the correct numbering is left to down. So this is 3 methyl. This is also 3 methyl. So what's the final name for this? Three. Dimethyl. And would you agree or disagree that this is the same exact molecule, different molecule. Same. Let's put things here. Or around. The longest continuous chain is still 6. And you have 2 methyls both on carbon 3. These are literally the same thing. Because what you have to understand is molecules are 3-dimensional. They move around. Yes. Go ahead. Okay. Now that I've brought this up to you.
This is skeleton.
What's your longest continuous carbon chain here?
Methyl.
What is chain here? What it be? What it is? Let me, I can see where it's at. It's 1, 2, 4, 5, 6. That's your longest carbon chain. Do you agree? Left to right or right? Or right to left or left to right? Right to left. Because this will give you your first substituent on 3, and the other one will give you your first substituent on 4. 4, 5, 6, 7. 7 means heptane is the end of the name. So what else? What would you do next? How many carbons is that? That's a 3-methyl, right? And how many carbons is this? So that's a 4-ethyl. So what would you name this?
3-methyl, 4-ethyl.
4-ethyl. You separate each constituent, right? So 4-ethyl. 3-methyl. Awesome. I said this lesson, it looks crazy at its outset. The more practice you get, the better it'll get. Follow the rules. I think we stepped it up a lot of notches. This next example I don't think is as crazy as the last one. This is the last one before I give you one to do yourself. So let's try this one. We can do this a little bit faster now. How many carbons in a row? First question. This one hopefully is easy to spot up.
5.
It's 5. 5 carbons. Notice I'm putting a line through them. The reason I'm putting a line through them is so that I don't accidentally name them again. I put a line through the ones that I know that I've already taken care of. This helps when you're looking at crazier molecules. 5 carbons is pentane. Then I circle my substituents there, here, here, and here. If I'm a visual person, I can already see. Is this left to right or right to left? More of my groups are on this side, so this means that this must be carbon 1. 1, 2, 3, 4, 5. What are the names of each of my groups? They're all the same type. 2-methyl, 2-methyl, and 4-methyl. So how would it? 2, 2, 4.
2, dimethyl.
2, 2, 4. Because there's 3 that are the same type.
Tri.
And if you have 3 that are the same, go back to the last rule down here, over here. If you've got 3 of the same type, we say tri. It would go pent. Tetrapent. Then it goes like that. 2, 2, 4. Trimethyl. And this is pentane. You ready for your turn? I left it blank on purpose because I created one. It's going to be skeletal. Ready? Next one is for you to try for a stamp. Name the following. I know you're very excited about this. 4 carbons in a row is cute, and then all we learned is single bond, so it's butane. So we know that this is 4 carbons. Right. In a row. And then we have these other 2 that are not in a row. And so that's where the ill name comes into play. The ill means that it's not part of the main set of carbons. And so this is only 1 carbon long, but it's off the chain. So we call it methyl. So, so you also have to say which carbon is on in this chain. So it's on carbon 2. We call it 2. We do the same thing here, because there's another one here. This is another methyl. It's also on carbon 2. 2. So 2 methyl and another 2 methyl. And so the way you put that together, because there's 2 of the same type, let's say 2 and 2, this guy. So this guy. Saying that I have 2 of them. Methyl. And then we end it with how many carbons there were. That's the general structure. Yes. You ready? Mm-hmm. Yeah. Only 5 in a row. Then you would get like an ISO group or an O group. So I intentionally left that out. But when they say like isopropyl alcohol, that's where the ISO group comes in. Yes. You ready? Have to find the longest carbon chain. The longest carbon chain. I'll go over it shortly. I'm giving you a little bit of time yourself first, though. Ready? The one that gives you the lowest set of numbers for your substituents. Your substituents with the lowest possible. Somebody's out when they come back. All right, looks like you all were not ready for that, or a few of you were. I think you get a sample.
This requires
I'll give you a couple more minutes.
some Disney level imagination.
You said Disney level. You got it. That's 2.
Doing some like military decoding here.
Talked about that with the water bottle yesterday. Like you can only have transparent water bottles. Like you can read the Morse code. I'll go over the answer shortly, but you're supposed to try to figure this out yourself. I'm gonna come back. Remember, you want the lowest numbered substituents possible. There should never be a substituent on carbon 1. That would be part of the chain.
I feel like I'm decoding German.
All right, I'm gonna go ahead and go over it. 1, 2, 3, 4, 5. This would be the correct order of numbering because it puts 2 groups on carbon 2. Whereas if you went left to right, you would only put 1 group on carbon 2. It should be right to left. So I know that it's 5 carbons in a row, which means that it's pentane. And this is where I said you may want colors because now I know that I've taken care of these should not rename them.
What if we did the same?
Then it would be wrong. Unless you wrote the whole thing backwards and you wrote the two methyl groups on the left side instead of the right side. You need to number with the lowest number possible or else it's not correct. So then, on carbon 2, I've got one carbon hanging out there. That's a methyl group. Do you agree? 2 methyl. This is another 2 methyl. This is a 3 ethyl. Some of you got this. And this is a 4 ethyl. So you're supposed to diagram it. Make sure you're following me. Or sorry, 4 methyl. Make sure you're diagramming it for each step as you go along. Finally, what do we do now? Alphabetize. Ethyl comes first. 3 ethyl. Then you'll have 3 different methyl groups. 2 on carbon 2 and 1 on carbon 4. So we would call that 2, 2, 4, and what? There's 3 different methyl groups. So we call that and then okay. Make sure you write it down. You will need to be able to interpret from skeletal, structural, and display formats, all 3 different things. The good news is that the last set of questions should be easier. The last thing we do. So I don't feel like we'll be stepping it up more notches. We already stepped it up the most notches for the day. But we do have to go over one more thing, which is if I give you the name, how do you draw it out? So we've talked about if I give you the structure, how do you name it? But you may also be given the name, and then you have to know how to draw it out properly in all 3 formats. So we have to end with that. It is simpler to do, is the good news. So, draw the display formula for 3-methylhexane. What if you were asked to draw, and they give you the name? What do you think you should do first?
Figure out the pairing name.
Exactly. Beautiful. Start with how many carbons you have in a row, right? This is the parent chain. We know that it's 6 carbons in a row. And the beauty of drawing it yourself is you can draw it however you like, meaning you can number left to right, or you can number right to left, or you can like go up and down. It depends on how spicy you want to be. I'm going to do it quite vanilla, as to not be confusing as much as possible. Can you take the pass? Okay. Yeah. Somebody else asked.
Someone writes it like we're going to Matches.
1, 2, 3, 4, 5, 6. Good with this so far? Now, after the parent chain. Oh, sorry, 10. Sorry, guys. Oh, did we? That's what happened. It's supposed to be here. It switched the slide. It switched the slide when I opened up the door. Sorry about that. So 6 carbons. 1, 2, 3, 4, 5, 6. Now what? We got to take care of the 3-methyl.
Yeah.
What does that mean?
Methyl is
So on carbon 3, we've got 1 carbon. Like I said, you can go left to right or you can go right to left. The decision is yours. I told you I'm going to be vanilla and I'm just going to go left to right. So, but if you want to be spicy, you could go right to left. So I'm going to number my carbon chain left to right. And then on carbon 3, there's a carbon coming out.
doesn't matter. It doesn't go positive.
It doesn't matter if it goes up or down. My arm can go up. Like it doesn't matter. These are once again 3-dimensional, they move around. Now what? I'm not done. I'm being asked for display formula. What else do I have to give you after I give you the carbon? I have to give you all of the
Hydrogen.
hydrogen. And you've got to know that every carbon makes a total of 4 bonds. You've got to internalize this. And if a carbon is not attached to a carbon, it's attached to a
Hydrogen.
hydrogen. So hydrogens just fill up the rest of the space. So this carbon on the left is going to get 3 hydrogens to go up to 4 bonds. This one's going to get 2 hydrogens. How many hydrogens will carbon 3 get? 1.
1.
And then 3 up here. Yep. Wouldn't it be nicer to write this in skeletal? I would love to write. If I was asked to write it in skeletal, 1, 2, 3, 4, 5, 6, it would just be that. I have to write so much. I'll mention now on your final test, you are going to have a larger written portion because there's a lot of writing in here. It's going to be about half and half. In the written portion, there will be a few questions that say you have to write in a specific type, displayed or structural and skeletal. But for many of the questions, it'll say write in whichever type you prefer. So if you prefer display formula, you can just draw every bond. If you prefer structural, you can do it that way. Or if you prefer skeletal, you can write all those questions in that way. So when it says any type of light, then you just write in your preferred format for your understanding. Yeah? Yes. And that was from the first lesson. Displayed means you must write every single bond. And the thing about Cambridge is they're really picky about it. So if they tell you displayed and you don't write displayed, you're not getting the point. Like it's like that. So that's why I'm going to be really picky on your final exam about that. If I ask you displayed, then I want to see displayed. If I ask you for structural, then I want to see structural. If I ask you for skeletal, then I want to see skeletal. But if I tell you to write any type you like, then you write your preferred format. Which many Cambridge questions are like that as well, where you can just write whichever version you prefer. The CH3, CH2, CH thing. That's this one. So here we go. Draw the structural format just to get you some practice with each type. 2,2,4 trimethyl pentane. I would still start by writing my carbons out and then figuring out where to go from there. So pentane means what? 5 carbons. Okay. 1, 2, 3, 4, 5. Just to like give my structure of what it's supposed to look like. Now what do I do?
Figure out the. So there's going to be
Vanilla. So left to right.
1, 2.
Gonna need a carbon here, a carbon here. 1 up, 1 down. For 2 and 2 methyl. And then on carbon 4, it doesn't matter if you go up or down. It's not gonna end up looking like that anyway. This is what we call a carbon skeleton. It's just to help us figure out how the molecule is organized. But this is not the structural format. What's the structural format? Atom hydrogen and you group them together. So here's where you may want your colors again. This is what I suggest. Remember that when you're doing structural, you group everything so the carbon on the chain is on. So we start right here. How many hydrogens are on that carbon? So you write CH3. That makes sense. CH3. Then we go to the second carbon in the chain, and we look at what that's attached to. Be careful here. It is attached to no hydrogens. It is attached to methyl groups. So how would you write those? Parentheses. And this is, because you have to understand this is like a CH3 here, right? And this is a CH3. So it's CH3 parentheses, what number was on the outside? 2 of them. So if you have more than 1 atom attached, you need to use parentheses to say that all of that is attached to that carbon. So that's what the parentheses indicates. You don't use parentheses for hydrogen because it's a single atom. You only use parentheses if it's more than 1 atom. Now we go to carbon 3. How many hydrogens here? So you write CH2. Carbon 4. Got a carbon 4. Are there any hydrogens on carbon 4? Are there? One. So you write CH. And then you still have this thing here. That's a CH3. How do you write that? And then you write your carbon 5, which is CH. Notice how I do structural. You do every carbon in the chain. You look at what's attached and you write it next to it. This actually allows you to be able to write your answers like in Microsoft Word. So you could actually just with subscripts and parentheses have your answers instead of having to draw everything out like the other two formats. Therefore, before I go on to your next example, I just want to bring up this is actually Cambridge's preferred method of presenting questions to you because it could just be typed in. And that's why this is actually Cambridge's preferred way to present things. So like on paper one, this is how they will likely look most of your practice problems. Harder for you, but easier. It is what it is. Some people actually last year, some students told me that this was their favorite type. I was like, oh.
They were weird.
So,
No, honestly, I feel like that. I feel like teach really in the non-understanding where.
like where the carbons and the hydrogens are.
And the other one's just.
This one kind of, it's a lot of work. Try one more of this type. So structural formula for 2,3-dimethyl pentane. How many carbons in a row for pentane? What do we got here? Pentane means
5.
5. This time we've got, I'm going to be vanilla. So 1, 2, 3, 4, 5. Don't have 5 for twice. On carbon 2, we've got a methyl. And on carbon 3, we've got a methyl. So how do we translate this now to structural? Carbon 1, what do we write? 3. How many hydrogens?
3.
Carbon 2, what do we write? How many hydrogens?
1.
And then you've also got a methyl. Methyls need to be written in parentheses.
CH3.
And here,
Another.
another methyl, right? Parentheses. And then what about carbon 4? CH2, carbon 5,
CH3.
and that's it. I should have one example of a skeletal before we close out. Look at that. All right, so one more example together, and then you'll have one to track where you have to get all 3 formats if you're able to do it before we go. Last example together on the next one. 3,4-diethyl skeleton. Heptane means what? So what does that look like in skeletal? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Heptane. Again, I'm going to keep it vanilla. 1, 2, 3, 4, 5, 6, 7. I'm going to bring my carbon chains left to right. To do that, I can read it. No matter how you draw it, how spicy you want to be, as long as you follow the rules. On carbon 3, what does it need to be?
2.
2 carbons in a row. So how would I write that skeletal?
One stick going up, another stick going down.
That. It has to be 2 coming out, right? 1, 2. It has to be 2 in a row. If you do 1 up and 1 down, that's dimethyl. That's not methyl. On carbon 3, got 2 coming out. What else? On carbon 4, I've got. Okay, right? That's it. That is 3,4-diethyl heptane in skeletal version. All right, so I've got your homework. There's one more practice question for you to try yourself before we go. And I have your homework. Just so you're aware, what day are we on? We're on Tuesday. On Thursday, I know some of you are going to the psychology test. For those of you going to the psychology test, I will be putting up the puzzle notes for you because we are going to do a lesson that day. But it won't be as intense as this one, I promise you. It'll be more of the same, just with a couple of different scenarios. You do have homework that is due next class. There's no back. It's the good news. So it's only the front page here. I'll be passing this out now. What? I'll be checking that if I have time after or during next time spell work. Crazy, but decided to go the opposite way.
How you know you learn?
There you go. Don't forget, if you didn't get to watch that ed puzzle lesson on the first part of the unit, make sure to do so. If you weren't here that day, then you have until the weekend. Otherwise, you need to do it today. You were here that day.
Good.